Hello, my name is Benjamin.caplins. I'm a researcher at the National Institute of Standards and Technology in Boulder, Colorado. And today I'll talk to you about a method we're developing for the voltage and bowl correction of delayed evaporation multi-hit events. So one of the goals we have at NIST is to extract as much information as possible from these atom probe data sets. So basically let no ion be uncounted if it doesn't need to be. And so one way of extracting more information is to look at these correlation histograms. So here's some work from Karen Kruska and Dan Schreiber, where they noted that the red dots in this correlation histogram are the events or the ions that are typically counted and ranged. The green dots are the ones that are typically just background. However, there's quite a bit of structure here, and where there's structure, there's information. And so with some help from David Saxe's work, they noted that you can replot these in a histogram across delta time of flight space. You get out these nice sharp peaks, and you can actually recover the majority of this background. You can assign them, and you can see how that might bias a composition measurement. So we have some data which was taken at relatively high fields, so there's a decent amount of background, and also with very long periods for the laser, so low repetition rates. And so we think that this DC evaporation is worth investigating, and so we'd like to kind of do this type of analysis. And so naturally, when we went to do it, it didn't work that well. So basically, in this lower left quadrant of this time correlation histogram, what you see is a lot of cross peaks, as you'd expect, and you also see these diagonal lines, which are the events that are correlated to each other, but uncorrelated to the laser pulse. Up at this upper right quadrant, what you see, unfortunately, is instead of these sharp lines, which we might be able to interpret, we see these diffuse bands that contain very little to no information. So the question is, this is the region we actually want to be analyzing for the purposes of this work, and so why are these bands? What's happening here? So what we eventually figured out was it's an issue of time zero. So time zero is simply not well defined for these events that are uncorrelated to the laser. And so the reason that's a problem is because the voltage and bowl correction need this T0 corrected time. And so what happens when you use the wrong time is you actually uncorrect the data, you deteriorate the data. So for example, at 5 microseconds, you're applying roughly 10 times more voltage and bowl than you should be. And so the question is, can we do better? So a first order way of trying to fix this, so a voltage and bowl correction for these laser uncorrelated multi-hit events, we approached as follows. We determined the voltage and bowl corrections from the single hit data, or the 1D histogram data, and then we use the time of flight. We actually subtract off this number that's given by a function delta, and this is a function of the flight times for a set of multi-hit events. And then we add that back on once the voltage and bowl corrections are completed, because that way we don't overcorrect. And so this function delta is really just an estimate for T0. And the simplest estimate we could come up with that seemed to be reasonable was simply take the mean time of a set of multi-hit events and then subtract off an empirically determined constant. So how does this actually work in practice? It actually works surprisingly well. So if you now look up at this upper right region of this correlation histogram, you can see all those broad diffuse bands are now very sharp lines. Kind of interestingly, if you look at this lower left quadrant, where you'd expect to see very sharp cross peaks, those have now turned into somewhat diffuse peaks. And if you think about it for a little bit, you realize that makes sense, because instead of using the time zero that was very accurate for these laser correlated events, we threw that out the door and ended up using this very rough, crude approximation delta. So some final thoughts are that the naive assumption for T0 is not correct for these events that are uncorrelated to the laser pulse. And this means that the voltage and bowl corrections actually deteriorate the uncorrelated data. A first order correction works surprisingly well. Determining this function delta may actually be a good application of machine learning methods. Right now it has a single free parameter, but the data may support quite a number of free parameters and may improve the correction a bit. These type of corrections really need the rawest form of the data possible, and they need to be in portable data file formats. And furthermore, this work was all done in Python because, to my knowledge, existing software packages don't let you explore these type of things very easily. And future work will go into developing and identifying we'll go up into identifying the peaks in this delta T histogram and trying to quantify and extrapolate those to the full time between laser pulses to see how that may affect composition. So thank you for listening. Thanks to the funding sources, and please feel free to contact me at benjamin.caplins@nist.gov if you have any questions or suggestions. I'd be happy to hear them. Thank you.
So we've got a question, whether or not have you looked at something like doing Huff transforms in order to arrange correlated events? Is that something you've been considering?
That's not something I've looked at, and I wouldn't actually understand exactly how to use it. So I'd be happy to talk some more to understand how to use a Huff in that context.
In terms of the T0 information, you're extracting that from the sort of the other ions within the spectrum rather than just the multi-hit ions, if I've understood you correctly. So in terms of, do you think it's possible to gain both this extra information that you're getting that allows you to sharpen these additional broad peaks as well as to maintain the original mass spectrum? Because it looks like there's a trade-off, one or the other, but it's not clear if you can get both.
Yeah, so that's, in theory, it should be possible. So basically, if you were to look at that, if you rotate those correlation histograms 45 degrees and remap them, then what you would see is at a cross peak, everything is very sharp because T0 is exact. And as you move away from T0, both to negative and positive time, things get broad. So if you appropriately parameterize that two-dimensional space, you should be able to put a lot of the information back together. From a pragmatic perspective, I was interested in 1 microsecond and onward. So if I mess up the early times, I can just treat those as 2 separate cases.
Okay, so I guess we've got a question. Someone's asking whether or not this is actually simulated data. I think you're probably best positioned to answer that one.
It is all very real data with all the problems associated with it.
Excellent. Yeah, no, it's great to see that you can actually get these statistical improvements out of the data. So how do you see this going forwards in terms of making the kind of code available or these kinds of analyses available to the community?
So at present, it's just under research development state. Very broadly, the things you need to make this type of thing work is you need voltage and bowl corrections that you can do yourself. And so, those are things we've kind of worked up in-house. They're not perfect by any stretch, but eventually we like to share those. But anybody's welcome to contact me for code, and hopefully eventually it'll be available online. We have some previous code in a similar flavor of work that was published on GitHub recently, but this is not yet ready for that.
Okay, and I think there was just one comment from a user. They're sort of maybe thinking about some work. Apparently, Yimeng Cheng may have done some work regarding that as well. So it'd be interesting to see if you think there's any additional information that you guys can pull out together. I'm not exactly certain what the questioner is implying in terms of how you could combine those two efforts, but I think it would be worth having a bit of a chat with that user. All right, thank you.
Sounds fantastic. Thank you.